This video, we are starting with percentiles. We're looking at the pth percentile. If a value is considered the pth percentile, that means the data value has the p percentage of data values that are less than x. So whatever the percentile is, it represents the amount of percentage of data that is less than the value you're talking about. So an example, if your child's height measures in the 60th percentile, that means 60% of the children are shorter than your child, and then 40% of the children are taller than your child. So the way we would calculate percentile for a given data value, we would take the number of data values less than that value and divide it by the total number of data values, multiply it times 100. So a quick example on that. On a reading examination given to 900 students, Elaine's score of 602 was higher than the scores of 576 students who took the exam. What is the percentile for Elaine's score? So you take all the values that are less than the 602 that Elaine scored, so that was 576, place it over the total number of data values, which was 900. Total number of examinations was 900. So 576 divided by 900 is 0.64. Times that by 100, and that's 64. So that means Elaine's score of 602 places her at the 64th percentile. The next thing we'll talk about in this video are quartiles. They're data values that split your data set into fourths. So you have your minimum and maximum value as bookends. Then you have Q1, Q2, Q3, quartile 1, quartile 2, and quartile 3. So the way we find our quartiles, just remember that they are all medians. They're all middle values. So first thing we're going to do, just like when we're trying to find the median, is list our data values from least to greatest. Then from there, we'll find Q2. So we'll find the median of the whole data set. Q2 is going to be the middle value of the whole data set. Then we'll find Q1. Q1 is the middle value or the median of the first half of data. And then Q3 is the median or middle value of the second half of data. All right, so let's put it to work. Here's an example. We have the following table lists the calories per 100 milliliters of 25 popular sodas. Find the quartiles of each. So we have 25 data values here. First step is to list them from least to greatest. So we have 26, 32, 36, 36, 37, 39, 39, 40, 40, 41, 42, 42. Since we have 25 data values, I put the middle value right here, which is 43. So that's 12 on top. Then we have 12 on bottom, 45, 45, 48, 48, 49, 50, 53, 53, 56, 58, 62, 73. So we have 12 data values on top, 12 data values on bottom. Then we have this middle value right here. Number 43 is the middle value. So Q2 is the middle value of the whole data set. So that's why I set 43 right here, because that's my Q2. No calculation needed. Remember, whenever you find the medians, if you have an odd number of data values, all you do is choose the middle value, and that was 43 for us. Now finding Q1. Q1 is the middle value of the first half of data. We have 12 data values on top. That's the first half of data. Now we have 12 numbers, so that means we don't have an actual middle value. Whenever you have an even number of data values, you take the two middle values, add them together, and divide by 2. So that ends up being 39, because 39 and 39 are two middle values. Then we have 12 values in the second half of data, and that's what we'll do the same thing. 50 and 53 will be our two middle values. Add them together, divide by 2, that's 51.5. So Q1 is 39, Q2 is 43, and Q3 is 51.5. Last thing in this video, box and whisker plots, or just box plots for short. They're a visual aid used to provide a summary of a set of data. It is made up of a box with lines that extend from it to the minimum and to the maximum values. Those lines are called whiskers, and it's drawn by using the minimum, Q1, Q2, Q3, and the maximum. So we'll take on this form right here. And so if we use the data values from the previous example, 26 will be our minimum, 73 is our maximum, then we'll use 39, 43, and 51.5 as the lines in our box. Let me know if you have any questions.